Alright, in the last video we introduced multiplication principle with dependent probabilities and conditional events. Right, when we solve these types of applications where we're given in the application conditional probabilities, and usually they're given as a percent, we solve them by setting up a tree diagram. A tree is a way to organize all of our outcomes possible. Right? So it is a probability distribution when we set up a tree based on our two events. Right? And then the conditional, right, the second event is based on the condition of the first event. Right? So these are when we're given conditional applications, and we'll solve them using trees. Right, so the first example. Right, suppose that we have statistical information on a basketball player. We know based on her statistics, so these would be estimated probabilities based on statistics, that she will make her first free throw 70%. So when you shoot a free throw, we're assuming the statistical data is based on the fact she's shooting two free throws, right? You shoot one free throw and then the next. 70% of her time that she shoots, the first free throw will go in, which means she'll miss it 30% of the time, right? 100% of the outcomes. When this happens, she'll make her second shot 90% of the time, but if she misses the first shot, only 80% of the second shot will be made. All right, so where you have to sort of recognize this isn't the Venn case that we did in the basic probability type in the earlier sections. We have to recognize that these are conditional probabilities, conditional percents. This 90% is based on the condition that she made the first free throw, right? When this happens means the first free throw was made. She'll make the second free throw 90% of the time, right? That's a conditional probability. But if she misses the first shot, so given she missed the first one, which happens 30% of the time, her second shot odds go down by 10%, right? She only makes them 80% of the time. Those are conditional probabilities. The second set of conditions, the second free throw, is based on what she did on the first free throw. Right, so it's conditional, and so I have to set up a tree. So I'm going to set up a tree. Now, you might be able to solve this without a tree, but again, trees just make it easier. It's a way to organize my conditionals and all my outcomes. All right, because we're going to answer these questions. We want to know the probability that she'll make both free throws, the probability she makes at least one. I'm going to solve these after I set up the tree. Right, so setting up the tree. Well, she has her first free throw. And then the second. Then all outcomes. Alright, so it is a probability distribution. It's going to list all the things that can happen when she shoots two free throws and all the probabilities that go with them. Right, so the first free throw, there's two branches, right? When you shoot a free throw, there's two things that can happen. Either you make the free throw, and so I'm going to let M be she made it, and M prime she did not make it. So that's the two things that can happen, right? When you shoot a free throw, when you shoot a basket, either it's going to go in and you made it, or it's not going to go in and you missed it. Right? She has a probability. Right? She had a 70% chance she'll make the first free throw, right? 70% chance she makes it. So you always write the probabilities on the tree. Never write the percents, because we're going to multiply. You can only multiply the decimals of the fractions. All right, so always convert to the decimal if you have a percent. So this is 0.7, right? 70% chance she makes it is a probability of 0.7. Well, if she has a probability of 0.7 of making it, remember these are all of our outcomes, so these should add up to 1, right? 100% of the outcomes when you shoot free throw. Well, she's got a 30% chance of missing it, and so that probability is 0.3, right? She's got a probability of 0.3. She'll miss the first one, right? That's 1 when you add them up, because that's 100% of the outcomes when you shoot a free throw. Then you've got your second free throw. Now, you only shoot the second one after you've done something on the first, right? So either you're going to make the first or miss the first, and based on what happens on those two, the second probabilities have a different outcome. All right, so you've got the second set of branches here. All right, again, you can make it or miss it, make it or not make it. All right, these are your conditionals. All right, the condition is, well, what happened on the first event, right? That's the condition. So suppose that you're down this path, right? You're the 70% of the outcomes are she makes the first one. If she makes the first one, right? When this happens, she makes her first free, so she's in the 70%. She makes the second shot 90% of the time. So given she makes the first, there's a 90% chance she'll make the second. So remember, we write that as a decimal. 90% as a decimal is 0.1. These are all of the outcomes in the second free throw after she's shot and made the first one. Alright, so these should add up to 1. There's a 90% or 0.9 probability she'll make the second, which means there's a 10% chance she won't make it, so a probability of 0.1, right? This should add up to 1. Right? This is all of the outcomes on the second free throw after she's made the first one. Alright, and so 90% chance she makes it, 10% chance she misses the second free throw. Right, then we do the other outcome, right? So given there's 30% of the time she misses the first shot. Right, if she misses the first shot, the second shot has different outcomes, right? It's a conditional based on she missed it. So if she misses it, which are 30% chance, given that that was the case we're in, she'll make the second shot only 80% of the time. So it lowers, right? We only have 80% chance the second one will go in. So this is 0.8, right? 80% chance is a probability of 0.8. So given she missed the first, the chance she makes the second is 80%, 0.8. These are all of the outcomes where when she shoots the second free throw after she misses the first. And so this probability should add up to 1, and so the probability that she misses the second, given she missed the first, well, that's 0.2, right? That has to add up to 1. So there's 20% of the time, she will miss the second free throw if she missed the first free throw. Right? And then at the end of the tree are all the outcomes. Right? She makes the first and makes the second. Makes the first but misses the second. Misses the first, made the second. Misses them both, right? Misses the first, misses the second. And that's all of our outcomes. Right? That's all the possibilities when you shoot 2 free throws. Right? So that would be a probability distribution which should add up to 1 at the end as well. Right? Either she makes them both, she misses them both, or she makes one and misses one. And the two different ways that can happen, where she can make the first, miss the second, miss the first, make the second. And they're different odds based on her statistical numbers which of those outcomes happen. Right? You find it by multiplying down your tree, right? 70% of the shots are made the first time. 90% of the second shots then are made. So she makes them both. 0.7 times 0.9 comes out to 0.63. So the probability that she makes them both is 0.63. I'll talk about that in terms of percents, meaning out of all of the free throws where she shoots 2, right, so she's shooting 2, out of all of her free throw cases, 63% of the time she makes both the first and the second. Alright, then I do the next case. She makes the first but misses the second, so 70.7 times 0.1 comes out 0.07. And so the probability she makes the first and then misses the second is a 0.07, or 7% of the time when she shoots both free throws, she will make the first and miss the second. And if you look at this, which I mentioned this when we went over the generic case, these are all of the outcomes where she made the first, right? These are both of the outcomes where the first shot was made, which is 70% of the outcomes. If you add 0.63 plus the 0.07, that adds up to 0.7. Right? Those are the 70% of the cases where she makes the first. 63% of those 70 cases, she makes the second. 7% of those cases, she misses the second, right, based on her stats. Right, and again, that will happen here too. These two should add up to 30% of the outcomes where the first shot was missed. All right, so we do the same thing. So we take our 0.3, which is the probability she misses it, and then the probability she makes the second. So 0.3 times 0.8 comes out 0.24. So the probability she misses the first but then makes the second is 0.24. So there's a 24% chance She misses the first free throw, but then makes the second free throw. Alright, and so that's that case, 24% chance. And so the probability that she misses one and makes one is different depending on what order you're in, right? The probability of making the first and missing the second is only 7% chance. The probability of missing the first and making the second is 24% based on our numbers. Alright, then the last probability, she misses them both. So 30% chance she misses the first times the 20% chance she misses the second, given she misses the first, comes out to 0.06. Alright, so probability that she makes them both is 0.06. These are 30% of the outcomes, right? If you take your 0.24 plus your 0.06, it adds up to the 0.03. And that should make sense because these are all of the cases where the first free throw is missed, right? 30% of them. 24 of those 30%, she makes the second one. 6 of those 30%, she missed both. Right? And again, if you add this up, this should add up to 1, all of my outcomes. Alright, so there's my tree. Alright, now we'll answer the question. Alright, so based on my information, what's the probability that she'll make them both? So this is the probability she makes the first and she makes the second. Well, that's this outcome. 0.63. Alright, 63% chance she makes them both. Right, and that is based on, you could have used the formula as the probability she makes the first times the probability she made the second, given she made the first. Which that probability she made the first was 0.7. Probability she makes the second, given she made the first, well, that was that 0.9. Right, you take 0.7. That's what we did to find the 0.63. You take your 0.7. So it is that formula. It's just built into the tree. Right? So 0.7 times 0.9 is that 6.3. Which, again, usually students don't do this. And, again, I encourage you to set up the tree to find it. Alright, the second case, which I'm going to give myself a little more room to write, is the probability she makes at least one of them. So at least one of them means one is made or more, alright, which means both of them are made. So you make one or more. There's two ways to do this. You could use the complement, which would be 1 minus the probability. Well, we want to get rid of the outcome where she's not making at least one. So that would be the outcome where she missed both. Which is, again, probably the quicker way to go, because it would be 1 minus the probability she missed them both, which was 0.06. And then we find that that's 0.94. Alright, so there is a 94% chance she's going to make, when she goes up to shoot her free throws based on her stats, that she makes at least one of them. Alright, and that's using the complement. The alternative to that was you could have added up all of the cases where she makes at least one. Right? These would be all the cases where she makes at least one. If you add them up, it should add up to that 0.94. Right, so it should work out either way. And you can do it either way. It doesn't really matter. Whichever way makes most sense to you, do it that way. Alright, the second example on this page, and we're going to do the second example, and we'll probably stop there because these are sort of basic setups. I don't want to make these videos too long. This second example was one that was actually on an old final exam where, again, it's been a few years ago now, but I pulled it and decided to put it in my notes because a lot of students had questions on it. Because they just had a hard time being able to set this up because there is a little trick to it. But once you've seen the trick, once you've seen what's going to happen in this case, you should be able to duplicate it. Alright, so we've got 30% of Miss Speller's third grade class passed their spelling test on the first try. Any student failing the test may retake. 40% of those students who retest pass on the second try. So this is a conditional case. What you have to recognize is the condition. It's 40% of those students who retest. Meaning it's not 40% of all of my students, right? It's just 40% of those who didn't pass on the first try. So it's 40% of the 70% who didn't pass on the first go. It's a condition, right? Only those who don't pass have to retest, and there's only a percentage of those who will eventually pass. And we want to know what that percent is, right? What percent of Miss Speller's third grade class will eventually pass on either the first try or the second try? All right, so we're looking for the probability they will pass on either try. Alright, that's the final question. But I'm going to solve this with a tree. Alright, so we have the first test and then the second retest. Alright, and then all outcomes. Alright, so the first test, there's a probability they pass and there's a probability they fail. Alright, well that's this percent. Right? 30% of the class pass on the first try, which means it's a probability of 0.3 that they pass on the first try. Well, if 30% pass on the first try, that means 70% don't pass. And so 0.7 is the probability they fail on the first test. The tricky part about this one is, if they pass on the first test, they don't have to retest. So any student failing the test may retest. So if you didn't fail, if you passed it, you don't retest. And so this ends. This set of branches doesn't have another set. It's done. You just kind of go to the end here. Probability that they passed on the first test was 0.3. And you're done. You don't do anything with that one. It's the failed branch that will retest, and that's the only branch where you'll have, you know, another group of passing and not passing. And so you'll branch off for the second, and again, only this group where that failed will take the second test. And a certain percent of them will pass, and a certain percent of them will fail. Alright, and then all outcomes. This is the probability they failed, but then passed. And this is the probability they fail both. Alright, and that's all outcomes, right? Either you pass the first time, or you pass the second time, or you never pass on either time. Alright, so this is the conditions, right? These are the conditionals. Not everybody takes the test again. Right? Only 70% of the kids take this test again. So it's not everybody. That's why it's conditional, right? Conditional means it's only out of a group of the students. It's out of 70%. So if they retest, 40% of those two students who are retesting will pass on the second try. So 40%, so 0.4, will pass on the second try, right, of those who failed on the first try, which means 60%, so 0.6, will fail, so 60% not of the class, remember that's 60% of the 70% who failed. Right, and then all of the outcomes, so failed on the first but passed on the second would be 0.7 times 0.4, so that's 0.28, and then failed on both, 70% times 0.6, so 0.42. So 42% of the class failed on both tries, which again, we want the probability that they pass on either try, so these are the two cases we're looking for. Alright, we want to find the probability they passed the first time or the second time, and so you add those two cases up. So 0.3 passed on the first time, 0.28 passed on the second try, so 0.58, and we did want it as a percent, which is 58%. Alright, so the answer is 58%. 58% of the class, and it should make sense, you could actually use the complement. 42 don't pass on both tries, means 58% do. 58% eventually pass. 30% of them passed on the first go. 28% of them passed on the second go. Altogether, 58% passed. Alright, and like I said, that one was a tricky one because this was terminal, alright? Once you pass, you don't need to do another set of branches. So that ended on my first branch. There was no second set of branches there. And again, that's what kind of threw students off a little bit. But as soon as you've seen that case, you should be able to duplicate it, that can happen. Right? It just means, well, that's just one of my results, right? That's one of my outcomes is just passing on the first try. I didn't need a second set of branches on that case. Alright, we will stop there. We're still going to continue in the next few pages, setting up tree diagrams and solving. And again, I'm just going to do them in little clips so in case you want to go back and watch them, it's a little easier. Alright, so I'm going to stop this video there.